The following table gives us the number of people killed in rollover crashes of various types in vehicles in 2016. So there's your data. If a fatality due to a rollover crash in 2016 is picked at random, what is the probability that the victim was in A, a car, B, an SUV, or C, a pickup or an SUV? When you're dealing with probabilities, I mean, you first have to make sure you know, well, you have each outcome here. You're looking at these rollover crashes. They're all rollover crashes. And so you have the number of deaths in each type of vehicle. So what you want to do is first figure out what is your sample space. How many different individuals are in this? So there's 10,656 different rollover crashes in this study. So I need to know that because, I need to know like how many different, I mean, your total space is so I can come up with the probability. So if a fatality is picked at random, what's the probability it was by a car? Well, that would be 4,768 out of the 10,656, or 0.447 repeating. So if it's an SUV, well, that's just 2,448 over 10,656, or 0.2297 repeating. So the first two is, not part of the repeating pattern. A pickup or an SUV. Now, this is pretty straightforward because of the fact that, if someone was in a crash, they could not have been in a pickup and an SUV at the same time. Right? They're talking about what they were riding as passengers. I guess if a really bad accident, and you're not wearing your seatbelt, I guess you could be in one vehicle, go to the other. I don't never hear that happening. So basically, for me to figure out this probability, all I really have to do for this is just look at those two numbers together. Either add those together, take it out of 10,656, or I take the individual probabilities and then add them together. And when I get that, I get 0.4870495 repeating.